Hi everybody, hope we're doing great. Welcome pre-algebra students. You are wonderful. I hope you are all staying safe and healthy and getting outdoors once in a while just to get some fresh air. That is so good for you. I definitely miss you all so much. This is week three video on surface area and volume of solids. A solid figure is something that you can actually pick up and turn. You can see if you can picture this, how we have a front and a back. We've got two sides and we have a top and a bottom. If you can picture this being a little box. So that's what a solid figure is. If I just drew a rectangle, that would be a two-dimensional figure. You can't pick it up. You can't turn it. You're only looking at one of the faces. Now, a solid is something you can just really pick up and see. And in class, if we were in class, I would have a solid for you to pick up and look at and blah, 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 and measure and that kind of thing. But unfortunately, with the video, really can't do that. So the goal today is, by the way, I'm sure you're glad to be done with composite figures. That's probably the hardest part of the whole year. The good news is the rest of this year is going to be a whole lot easier. In fact, you have done today's video last year in Math 7. Doesn't mean I want you to hit pause or stop it. Please watch the video. Still try the homework. It's good to brush up on this for geometry. But basically, what we're going to do is find the surface area and the volume of these figures. What I'm going to do, just to save some time, is rather than do a whole bunch of surface area and then go back and do a whole bunch of volume, we're going to do both. We're going to do the surface area and the volume. You will normally get the formulas for this anytime we do this. If this was a quiz or test or SOL, you would have the actual formula. So the surface area, and again, this is right from your notes. So when you watch this video, if you don't have the notes, go ahead and hit pause and print off, if you can, the notes. It's the file that does not have the HW, so it should say pre-algebra surface area and volume of rectangular prisms. Yeah, without the HW. The HW would be the homework that we will I'll kind of ask you to do and turn in. All right, the surface area, and the same thing, by the way, with cylinders, when we do cylinders a little bit later. So surface area, what they say, what the state will give you is this formula. It's 2LW. You probably saw this last year, plus 2LH plus 2WH. So basically, you're going to use 2 L's, 2 W's, and 2 H's. It doesn't matter which order all this stuff is in, as long as you do everything. So this will basically be the front and the back, the top and the bottom, and the two sides. Remember, there's 6 faces. 1, 2, 3, 4, 5, 6. It's hard to visualize this without picking it up, but you just kind of have to see it. You got a top and a bottom, like I said earlier, the front and the back, and the two sides. So what we'll do is we'll give each one of these a dimension. This is going to be we'll call this the W, we'll call this the L, and we'll call this the height. And what you do now is just plug everything in. Now it's just a bunch of plugging everything in. So the surface area is going to be equal to 2, I like to use parentheses, times the L, which is 3. And all you're doing is literally labeling and then plugging everything in. It really doesn't get too much easier than this. Okay, plus, we're going to separate each one of these. Then we've got 2 again. By the way, the 2 means we have a top and the bottom, a front and a back, and 2 sides. So this is a shortcut to doing it. The L is 3, and the H is 4. Okay, and we got this part, the 2WH. I'll move it down here. Plus 2. W is also 2, and the height is 4. Now, just crunch the numbers. Do the multiplication first. So you're going to get 2 times 3 times 2, which is 12. So you go 12 plus. This is the surface area. So imagine that we're covering this in wrapping paper. So how much wrapping paper will we need to cover this entire box? This is surface area. So SA, surface area. So 12, 2 times 3 times 2 is 12, plus, that would go 2 times 3 times 4 is 24, plus, then we go 2 times 2 times 4, which is 16. We will add all of these together, and we will get 52. So we'll go 52 square feet, and we're done. What I'm going to do is I'm going to do 2 of each of these. I'll do two surface area and then 2 volume. Same thing with cylinders. Okay? You'll get the hang of this. This is actually really, really easy. It all looks hard with this formula and all this stuff. Just you practice it enough times, and it's going to be good. Okay, I'm going to kind of just talk while I erase and set up the next problem. I'll leave the formula. Might as well leave the formula. No need to erase that formula. So on your paper, if you're following along, I'm just going to pick another one real quick. Let me just draw this one. And while I'm writing, I'll just say, I just continue to hope and pray that all of you are doing great. Oh, by the way, when I was in school, one of the ways that my teacher taught us to draw a three-dimensional shape. See, I'll do a rectangle and then do another rectangle. And now I just kind of do this. I know it's ghetto, but kind of cool. It works. So you have here 8 meters is right off your paper. 8 meters. 8 meters again. This is obviously be a square, and it has a height of 5. So it's not quite a cube. A cube would be if they were all 8. This is 8, 8, and 5. So kind of just put your L, W, and H. So we'll call this the H. This is the height, how tall it is. The length and the width are really interchangeable. It doesn't really matter which one's which. We'll call this the L, this one the W. At the end of the day, it really doesn't matter which is which. But we'll make it, we'll do it so it makes sense. Okay, here we go again. So surface area, how much wrapping paper would we need to cover this? We would need, to find the surface area, we would need the top and the bottom. So we'll go 2 L W. I remember doing this problem last year. Plus 2 L. You're literally just plugging everything in. Surface area and volume are actually one of the easiest parts of the whole year because really, we're going to give you the formula. We're going to give everything you need. All you have to do is plug everything into the formula. Plus 2 WH. Okay, let's crunch the numbers. So you got, oh, by the way, make sure you have your calculator with you. Make sure you have your calculator with you, especially when we do the cylinders in a couple of minutes, because we're going to have pi, and it gets kind of messy. This one you can kind of get by without a calculator, but you're going to need a calculator at some point in this video. Okay, 8 times 8 times 2 is 64 times 2, which is 128. If this was a quiz, I would want to see all this work. This is good practice for geometry. 2 times 8 times 5 is going to be 80. And then 2 times 8 times 5 is also 80 again. Okay, so add them all up. You got 128 plus 80 plus 80. 80 plus 80 is 160. So we'll go 288 square meters. We'll always circle our answer, and we are done. So we took this little box here, and if we were to fill the outside, surface area is the outside, by the way. Volume is the inside. Surface area is the outside. Okay. Let's go ahead and do volume then. Volume, you're going to love volume. Volume is not as difficult. Volume is quicker. It's easier, the whole thing. Volume is going to be how much water does this hold. So volume is capacity. Okay, if you fill the inside. Surface area is the outside. Cover it in wrapping paper. Volume is the inside. So how much sand would you put in this? How much water would you put into this aquarium? Okay, volume is the capacity. If you're filling up a hot tub with water or a swimming pool with water, how much does it hold? So we're going to look at the inside. Well, this is a three-dimensional figure. So what we're going to do, we're going to go volume. Volume is going to be the length times the width times the height. It is literally that easy, folks. So what we're going to do is just take, really in any order, 8 times 8 times 5, and we're done. So 8 times 8 times 5, and what that's going to give you, well, 8 times 5 is 40. 40 times 8 is 320. We can go 320 meters cubed. Volume is going to be cubed because it is 3 dimensions. And that's it. It is literally boom, 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 done. If you really think about it, if you can picture this, if you take 8 times 8, which is 64, okay, that's the volume of the base. 8 times 8 is 64. That's the base. Well, if you take 64 and you go 5 times, we're going to go 1, 2, 3, 4, 5, because 5 is the height. That's what we're doing. We're taking 64 times 5 and getting 320. So imagine we're taking a rectangle or this square and we're just stacking it up 5 meters high. So we have the area of this square plus the area of this square, this square, this square, and this square, and this square, and we'll have 5 squares because it's 5 squares high. So square, 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 and we get 64 times 5, which is 320. And that is the volume of a shape. Okay, I'm going to take another problem that's in your notes that we haven't really looked at for, it really doesn't matter which ones we do and which ones we don't do in the notes, as long as you get the idea here. That's the idea. And then we have our virtual class. We will actually have a virtual class on Tuesday, April 28th. All right, we're aiming for that. We think that we have finally fixed Blackboard. We hope. We're crossing our fingers and all that stuff. Okay, let me just show you just a couple more volume, and then we'll get the cylinder, and that'll be it today. Really, just not a whole lot. On the notes, you'll see what we're talking about, like changing the dimensions and working backwards and that kind of thing. We're not going to ask you to do that for now. You're going to do a lot of that in geometry. Okay, we just want to show you just really what you need to know, just the basics. Okay, so here is the front of this, and again, I'm going to do it kind of the getaway. You can draw this with me if you want. It's kind of fun. And there you go. Looks like a box. Okay, this is 7. This is on the back side of your notes. 3 and 5. And we're going to centimeters. cm, centimeters, centimeter, centimeter. Okay, let's do the surface area first. Oh, no, we just did the volume. Yeah, let's do the volume. Volume is going to be length, volume, capital V, volume is LWH. That means it's length times width times height. You will not see the multiplication symbols here. Just LWH. So now what we're going to do is we're going to take 7, and really in any order, 7 times 3 times 5. And what we're going to have is 21. 7 times 3 is 21. Times 5 is 105. Now some of you might have gone, 5 times 3 is 15 times 7, which is 105, or 35 times 3 was 105. Remember, this is the associative property. The order you multiply these numbers doesn't matter. You're going to get 105 cubic centimeters, and we are done. So imagine this was a box of popcorn in the movie theater. How much popcorn can this box hold? And of course, you want to put the butter on, right? That's the best part. Butter is the best part. Okay, that is rectangular prisms. Again, I know you did this in Math 7 last year. It's just always good to brush up and see it a second time, just to really get you ready for geometry. By the way, next week we will be doing a couple of solids that you have not learned. We will be doing pyramids and cones. And boy, if we were in class, I would have actually have ice cream cones for you. I would have had a Hershey bar for you for this one. That's my tradition. I would have bought a Hershey bar for you and done that. But there's really no way to get that to you, unfortunately. Okay, cylinders. This is right off your notes, so if you don't have this in front of you now, this piece of paper, please print this out. This will be on Google Classroom or Blackboard. And I need to kind of explain this to you first. The cylinder, by the way, is just a can of soda. Okay, bottled water, cylinder, baked beans. You get the idea. So we're going to find the surface area, and then we'll find the volume on the back. This is a little hard to explain where this formula comes from, this weird formula, but basically, if you were to unravel it, you would have the top and the bottom of the cylinder and what's called the lateral surface. That's the midsection right here. So what we do is we'll take the circle. These are both circles. So we'll go circumference of the circle is pi, area of the circle is pi r squared, and there's 2 of them. That's how we get the 2 pi r squared. This is a little tricky. If you were to unravel this midsection, it become a rectangle. So we have a length times a height. Well, the length of the rectangle is also the circumference of the circle. It's very hard to understand this, but I just want to show you real quick where we get this formula. This is the formula we're going to use for surface area of a cylinder. This comes from any textbook, the SOL, formula sheet, anything right there. And again, you probably did this last year, kind of a weird formula. And I'm sure your teachers probably tried to do their best part to show you where this formula comes from, just like I just did. You don't have to know where the formula comes from. It's just like something I always like to do with my students, kind of show you how we get the formula. Anyway, let's just practice a few. I could just write right on this paper, but I like using the whiteboard. So I'm going to draw this. What I do with this, with the cylinder, is I just draw kind of like It's a circle, really, but it looks like more like a football. I just draw this down here. I draw this, and I make this a dotted line. Okay, not the best cylinder in the world. Okay, this is 9, and this is a radius of 6 yards. Okay, we want to find the surface area. Well, it's a weird formula. It's going to be 2 pi r squared plus 2 pi r h. And again, this is not hard. You just have to follow the formula and put everything in. Give me 10 seconds. Let me grab my phone, which has my calculator on it. So I'm going to use my calculator here, and let's just do this. So what I'm going to do is we are going to find the surface area of this cylinder. Stay with me on this, okay? Just a couple more minutes and we'll be done with this video. I never want these to be too long. Okay, so here's what you do. On your paper, please get used to writing this out. We're going to put 2, because there's 2 circles here. So pi r squared is a circle. There's 2 of them. So we're going to have 2 pi, 3.14, and then r, the radius of the circle is 6, and it's squared. So we're just going to just write it twice. I think if you go 6 squared, it's kind of confusing. I'm just going to write it all twice. So 2 pi r squared is this, plus, see the plus sign? We're going to add to it 2 pi r8. So 2, this is really just plug and chug everything in. Radius is 6, and the height is 9. You are literally taking all of the information into the formula and plugging it in. Now, the most common mistake students make is right through here when they crunch the numbers. You've got to get this part first. Don't try to do it all at once. Just do this part first. Get a number, and then do this part, get a number, and then add those two together. Please make sure you do it that way. So I'm going to take my calculator. Please do the same thing. So we're going to go 2 times 3.14 times 6 times 6, and we're going to get 226.08. Okay, that's this part. That's the top and the bottom. So far, we're going to cover this with wrapping paper and cover this with wrapping paper. Now, we're going to take the bottom part. So let's do the same thing. It just takes a minute, but we can do it. 2 times pi times 6 times 9 will be 339.12. I've had students tell me, I've been doing this for 21 years, I've had students tell me this is one of the easiest parts of the whole year, but you have to take your time and be very patient with this. It's not hard, but you got to really make sure you crunch these numbers the right way. Now, and add these together. I'm going to go ahead and just do this. 15, 6, 5. 565.2 yards squared. Remember, this is surface area, so square yards. Okay? Really, really want to make sure you take your cell phone and your calculator. Please, please, please. Okay? Make sure you have a cell phone with a calculator. Every cell phone has a calculator. Make sure you have just the basic calculator on your phone. Everybody does. Make sure you do. Okay. All right. Let's do another surface area. Or you know, let's just do. Yeah, we'll do another surface area. Okay, I'm going to erase this. Don't erase. I'm not going to erase the formula. Just be patient with me for a second. I really, really do miss you all a lot. I miss you all a lot. Sometimes, oh, by the way, sometimes they'll take a cylinder and they'll turn it sideways. They're just trying to trick you. They're just trying to trick you. So this is still a cylinder, sideways. 18 is the height. Even though it's flat on the ground, you got to imagine it's turned up. Okay, this is the height. This is how tall it is when it's standing up. And then you got a radius of 3. This is right off your paper. 3 centimeters. Okay, let's do it. Let's do it. Please, please do this with me. Please do these with me. You're not learning if you're not doing it with me. If all you're doing is watching a video, you're not helping yourself out. You learn things by doing them, not by watching them. Watching them is important, but doing them is what's going to help you learn it. So please do these with me. You know, I can't monitor who is and who isn't. It's just a trust issue. Okay? Please, please try these. These videos are never that long. I'm never going to ask you to do a whole lot of work. I promise you. Please try these with me. Okay. So we put all the numbers in. We put the 3 in for the R. We put the 3 in for the R. We put the 18 in for the height. 2 is 2. Pi is 3.14. All right. Take your calculator. Let's crunch the numbers. So 2 times 3.14 times 3 times 3 will give you 56.52. That's the first part. 56.52. By the way, that's these two. That's the area of the top and the bottom. Okay, you got to cover that with wrapping paper too. Now the whole midsection is going to be usually a larger number. Now we're going to take 2 times 3.14 times 3 times 18, and we're going to get 339, much bigger number, 339.12. Add these up. When you add these up, you're going to get 4, 6, 15, 9, 395.64 centimeters squared, and we are done. Okay. Normally I just say, who's got questions? Questions. Anybody have questions? Questions. I can't. By the way, I can still answer questions, by the way. You just have to email me, okay? Or during the live class that we have. We will have a live class on Tuesday. Unless Blackboard goes kaplooey again, we will have a live class. By the way, if it does go kaplooey again, go to Google Classroom. That is our backup the rest of the school year, okay? Always, that's your backup. Okay, Google Classroom, that's always going to work. Okay, that's always up and running. That's never going to go down. I don't imagine Google going down anytime soon. Google Classroom will always be up, okay? If Blackboard is up and we can do a class together, awesome. If it's not, go to Google Classroom and the same idea. Watch the video, print out the homework if you can, and just try it. Okay, hopefully it won't come to that, but just in case. All right, 2 more with volume, and then we're done. All right, let me draw. This is another kind of weird cylinder. This is on the back of your paper. Please turn over the back. If you don't have a printer, by the way, and I don't have a printer either, you can still have the file open on your computer or your laptop. Okay, so this is kind of a cylinder that's been kind of pushed down. Imagine if sometimes people take an empty can, and just kind of stomp it down. We used to do that when we were kids. This is centimeters, by the way. And now we want to find the volume. So how much water does this hold? How much soda does this hold? That kind of thing. All right, the volume is going to be very simple. The volume is just like the prism volumes, and volume is always a lot quicker and a lot easier. Volume is just going to be pi r squared times the height. Now, just indulge me for a second. Imagine you take the circle, kind of like we did before. We take the circle. Pi r squared is the area of a circle. Pi r squared is the area of a circle. So imagine, and by the way, this is a circle, even though it doesn't look like it. So imagine we start stacking circles on top of each other. Well, how many circles do we have stacked? We've got 4 of them. That's why we got to multiply it by the height, which is 4. Okay, I'm just doing my very best to explain to you where all these formulas come from. Okay, plug and chug, folks. That's all it is. Plug and chug. So we're going to go in parentheses, pi times the radius, which is 8, squared, 2 times, squared, write it twice, times the height, which is 4. Okay, now we're going to bust this out on our calculator. So 3.14 times 8 times 8 times 4 will give us our answer, which is 803.84 centimeters cubed. And that, ladies and gentlemen, is the volume of this. Okay. Ooh, already a 24-minute video. One more, and then I promise I'm done. We'll stop. One more, and then we're done. Okay, let me just erase the picture. I can leave the formula. No need to erase the formula. And this is another one on the back of your sheet. This is kind of a similar problem. This one's a little bit longer, though. All the way over here. They don't have the dotted line thing on the paper, but I'll go ahead and just add that right there. And this is a height of 10. Now, sometimes they're going to give you a diameter of the circle. They'll do that on purpose. The diameter is 20, but remember, we don't want the diameter. What do we want? I don't see a D here for diameter. We want the radius. So we're not going to use 20. We're going to use 10. We want half of it. So we're going to use 10 as the radius. Okay, the diameter is 20. We're going to use 10 as the R. All right, last problem for this week, and then we'll stop. So we're going to go 3.14 times the radius, which is 10, not 20. 10 times 10, because it's squared, times the height, again, which is 10. So basically what you have is 3.14 times 10 times 10 times 10. Please give it a try on your calculator. 3.14 times 10 times 10 times 10 will give you 3,140 feet cubed. And ladies and gentlemen, we are done. That is the volume of this weird looking cylinder. Trust me when I say it is a cylinder, I promise you. Okay, so please look for, on Blackboard or Google Classroom, look for a file with HW in the title. That's always the one that I'm going to ask you to turn in. Always look for the HW. If it has an HW, that's the one I'm going to want you to turn in. Okay, you all have been wonderful. Just if there's any questions, please, please, please email me. You have my email address. All right, love you all. Take care of yourselves. That's first and foremost. Take good care of yourself. And along the way, maybe do a little bit of math. See ya.